Good morning, friends. This is Dr. Babban Kumar once again. Yesterday, we saw real-world applications, industrial applications of embedded system. And now we'll be seeing very interesting controller, okay, PIC microcontroller. The 8051, Intel's 8051 that we saw yesterday and relevant applications, we did discuss some advanced controllers as well. The Intel's 8051 is, however, the most basic controller of the industrial standard, MCS 51 standard. And as we yesterday discussed that subsequently many derivatives in 8-bit family or MCS 51 compatible family are there in the market by various manufacturers. PIC is one such controller, microcontroller. Yesterday we saw how it actually emerged from Intel's 8051 to various advanced controllers from various manufacturers. So today's lecture we will try to take some glimpses, although it will not be possible to cover PIC completely because it takes one complete semester. It is a one semester course teaching complete PIC controller. The idea will be just to give you some glimpses, some idea, some understanding, and we'll see some small examples also of interfacing, real-world interfacing, including LCD and some 7 segments, etc. So input-output devices we'll see. I'll just give some details. Okay. Now PIC is actually PIC is a short form. Okay. The manufacturer of this PIC is Microchip technology, okay, and it is inferred from peripheral interface controller. Because see, microcontrollers are mainly these are meant for controlling job, okay, interface controlling. Unlike your DSPs, which are meant for data intensive operations, whereas your controllers are meant for controlling operation, interface controllers, controlling your peripherals, input output peripherals. They don't do data intensive operations, unlike your digital signal processing. Well, embedded systems can be developed by all the cores, including DSP and microcontrollers. So PIC is peripheral interface controller, short form is PIC. We'll try to see some history about PIC microcontrollers and its features, history and features of PIC controller. So these are the contents that I have listed over here. Little bit about the architecture, about PIC architecture, what all it comprises of, the memory structure, etc. We'll see the pin configurations, how it differs, or is it similar to your basic 8051. So pin configurations we will see. Memory organization we'll touch upon, and when we talk of memory, you know, there is RAM and there is ROM. So there is data memory and there is a program memory. So RAM is data memory, which is volatile in nature. ROM, which is a permanent memory, read-only memory, which is a program memory where the code is stored. Okay, and you will see now a very significant difference is there as compared to your Intel's in PIC when we talk of these memories, how these are fetched, the data or the code is fetched from this memory. So there is a significant difference. Then we'll see some more details like development tools, etc. Okay, so let us see first the PIC microcontroller history and features. Okay, we'll see that how the microprocessors and microcontroller is comparison yesterday also we touched upon. We'll see if there is some difference this time when it comes to PIC. Then the advantages of microcontroller, embedded system concept. We have already touched upon most of these things, but in the context of PIC, we'll try to see if there is something more to it. Then criteria for considering any microcontroller that we have already seen yesterday also. Then variations of speed, packaging, memory, and cost per unit, and affects choosing of MCU. So how should we go for PIC or not? That we'll see in terms of these particular features and parameters of selection. Then compare and contrast members of PIC family. We'll compare and see its variations and differentiate them with respect to different family members. There is low range, mid range, and high end range. So they are mainly categorized into 3 ranges: mid, low, and high end. Okay, then we'll compare PIC with microcontrollers offered by other manufacturers and various members of 80 family, various manufacturers of 8051. Okay, microcontroller versus microprocessor. This we have already seen yesterday, that general purpose microprocessors are like 8086 or 8286 or 386, Pentium, Motorola's, PowerPC family. These are all what we call general purpose processors, whereas microcontrollers are one which are dedicated to fixed task. Okay, they are not general purpose. And we have also seen that there is a, yesterday I was having block diagram over here which says that there is no RAM, ROM, input output ports, and on-chip serial communication, etc. in case of microprocessor. Okay, and therefore to make them functional, completely functional, to work like a complete microcomputer or to deal with the real world, we have to add these additional blocks like RAM, ROM, input output peripherals, and serial ports, etc., without which we cannot interface or interact with the real world. So these are something additional blocks which are required, whereas in the contrast, in case of controller, everything is on chip. Your RAM, ROM, all that is there on chip. And so therefore it is fully functional. You don't have to additionally include these kind of blocks. So you have to just make selection what is required. And in the market, there is a variety of family that we will see in case of PIC also, that you can make the selections. PIC will give you facility from, let's say, 1K to 2 megabytes of memory in case of ROM, and RAM also you have up to 4 kilobytes of RAM. So fully functional cores are available. Then in case of microprocessor, what happens is that because of these additional things, what happens, the system becomes bulkier and they're expensive as a result. But at the same time, there is an advantage that it gives you versatility and flexibility, because you can add whatever is required in the amount that you desire for, that suits your requirement. And on the other hand, your controller case, you have cost effectiveness, space effectiveness, but at the same time, this available RAM, ROM, they are fixed. You cannot change it, because once it is manufactured, you cannot change particular core. So try to understand the difference is that in microprocessor you have flexibility. You can tune, you can add on, you can subtract. So that all flexibility is with you. You can just do that. Whereas if you have one microcontroller chip, now you cannot change. Whatever is there, once selected is there. So that you have to compromise. But normally people select it in advance only. Whatever is required, they'll make a right choice. But once you make a right choice, and then if further you have some additional requirement, now you cannot change it. So you have to take into account beforehand, okay, that in future my requirement may change, so I can add, subtract something. So both the systems have its merits and demerits. Computing power is the critical consideration, okay, in case of microprocessor based systems, because your general purpose processors, you can add good power, okay, computing power. And in case of controller, space, power, and cost are the constraints and important characteristics. As we were discussing yesterday, at this point we have seen that microcontroller based embedded systems are actually cost driven, space driven, and power driven, because mostly these are battery operated systems, and microcontroller as such is recognized and known. It's driven by these 3 features: cost effectiveness, space effectiveness, and power efficiency. And the peripherals like analog, digital peripherals, like we saw yesterday, the mixed signal controllers, these peripherals are on chip available. So this is how it looks like in the block diagrammatic form, that there is a CPU, central processor, general purpose processor, and you add to it RAM, ROM, IO ports, timer, and serial port. So in the slide you can see that. I hope you are able to see the slides, and it makes a complete one So A states it's a general purpose processor system, and B is when everything is on chip, including CPU. In controllers, CPU is inbuilt. Okay, CPU is inbuilt, and on the same core, same wafer, the other cores are mounted, RAM, ROM, and these additional blocks. Now, when we go to the embedded systems, so microcontrollers for embedded systems. Okay, so how do we decide? So what is that? Microcontroller for embedded system. Basically, microprocessors and microcontrollers are widely used in embedded systems, and microprocessors, microcontrollers are basically, they work like a brain to the embedded system. They are the central core, okay, that resides inside any system. So it executes the program, and that works like a brain to the embedded system. Okay, this embedded system is controlled by its internal controller. Okay, and this controller can be anything like PIC. Today we'll be seeing PIC, so we'll see that how it works like a brain to any particular embedded system, and it is an internal controller to it. And typical ROM is burned for specific function. So like in case of PIC, it is going to be on chip, and that will be burned. We'll burn it. The firmware, we say the firmware, we'll burn that with a particular specific program. Let's say we want to control microwave oven, or we want to control some process automation in the industries, or elevator, or washing machine, or printer, fax, etc. These machines. So specific function program is firmware resides inside the controller, and that controller resides inside that particular system. For example, mouse is here. Okay, only one application software is burned into ROM. Like unlike your general purpose processor, in PIC also we will see that it is also another advanced version of the family of the controllers. Only one particular program is burned inside it. So there is a firmware which will reside inside the PIC core, and that will work for a particular functionality. So contrasting embedded system is a Pentium based PCs. Okay, so if you compare one PIC based embedded systems and other general purpose PC, then what happens is how do we differentiate? These are used for many number of applications, like we know Word, video game, internet surfing, etc. So that is the major difference. Okay, and your this PIC based embedded system or any other controller based embedded system, they'll work for a completely only one task dedicatedly, and nothing else. And x86 PC contains connected to various embedded products. Okay, now interesting thing is like your general purpose, like 8086 based or any other power PC based control, this general purpose computer, they are connected to multiple embedded products. For example, your computer on which you work in the office, or your any other purposes, it is connected to mouse, it is connected to the keyboard, it is connected to the CD-ROM, printer, or hard disk. So each of these individual peripherals, like your keyboard, mouse, these are input-output peripherals. These are embedded system in itself. There is a controller which resides inside. For example, mouse. In case of mouse, the controller resides inside it. Okay, there is a PIC, small tiny controller 8-pin chip, which resides inside the mouse, and that receives the commands from the CPU. Okay, that what is the particular location of my pointer. So this connectivity is there. So each of these devices, whether mouse or keyboard, it continuously, like when we press something in the keyboard, the ASCII code get exchanged between your CPU core and your this keypad. So we'll see one of the example of LCD interfacing. There also there is one controller residing inside it, and that makes the communication with the CPU. So there is two-way communication. There are two controllers which interact with each other. So each product is actually embedded system in itself, and together, when we join this together, it forms a complete general purpose computer. So what is the critical need of the embedded system? Less power space achieved by integrating more peripherals. This we have already seen. Now high-end embedded system uses CPU integrated with many functions that we have understood now. Like high-end embedded system, what will happen? That CPU integrated with many functions. Okay, and tray needs, and what we see in the market is now trend is invading PC system as well. in PC system also now number of functionalities are being added. Now there is a competition between the general purpose PCs and the embedded system market. Both are invading and trying to overlap and trying to match or compete each other. But both definitely they have their own trade-offs and their own merits, demerits, and strengths. Now emerging designs provide chip containing entire CPU. Now you must have seen that now market may when you go there is a CPU and you say that there is on-chip all IO chipsets. That what that chipset means is you have all the functionality, keyboard functionality, mouse functionality. So you don't have to have multiple boards inside your computer. So on-chip CPU plus input-output chipset is already there. Entire computer on a chip is there. So that is what the concepts are. So that is how the emerging trends, design trends are emerging. And x86 based are used for high-end embedded systems to shorten the development cycle. And therefore, there are different applications. Why it is important to take a look at this? Because PIC is not a PIC kind of control is not something which can be used everywhere. Okay, wherever you find requirement, it should be deployed on that particular application only. Because therefore, now when you will see that what are the capabilities of the PIC, you will realize that what matches the best. But otherwise, also the PIC, there is an amazing growth by the microchip technology that since they launched the first controller, there has been now variety of the controllers that are there available in the market, which can almost comply with every application. So initially it was intended for the industrial applications. Now almost all the rugged applications, they rely upon this PIC family. So whether it is consumer electronics or appliances, automotive industry, places of cell systems like point of sale systems, computer peripherals, development tools, everywhere these are now measurement equipments. These days you might see that your oscilloscope or your logic analyzers, these are high-end. Now they are becoming very high-end and becoming very, very intelligent. So they interact with the user, they capture your data, they capture your signal, they process, they do some signal processing as well, and they allow you for some math functionality also. So there are so many things that on the just touch. Now touch-based CROs, touch-based logic analyzers, multimeters are available. So these are all the embedded. This was possible only because of the embedded products. And inside this, specifically all these measurement equipments, PIC controllers are residing inside it. PIC controllers, multimeter, oscilloscope, logic analyzers. So PIC-based controllers are very widely used in the measurement equipments. So there is a huge market like Agilent or Tektronix or so these are the manufacturers, leading manufacturers, National Instruments, which are using this kind of controllers. Now, before we why we should be choosing the microcontroller like PIC. So choosing a microcontroller. So I think this we have already seen. So I'll try to skip this because computing needs definitely when it comes to speed, packaging, power consumption, RAM, ROM, IO pins, timers, upgrade to high performance or low power versions. So these are the kind of typical features that you will see in the PIC. Like there is a speed because of pipelining structure, RISC architecture, Harvard architecture. So there is a inbuilt capability. The speed wise, definitely one will get attracted to the PIC kind of controllers. Then packaging, it's very compact in size. Pin count starts from 8 pins to 100 pins and different like quad fat packages or thin film packages. There are different packages which are available there, PLCC packages, and power consumption is also very low. RAM ROM is something that is the best available in this class. As I was telling that it facilitates, you'll see one of its kind of feature that it has a program counter which is a 21-bit kind of program counter. So it can, the addressability is up to as high as 2 megabytes. Because in 8051 what we see is that there is up to 64K because your address lines are up to 16. So 2 to the power 16 is 64K. It can go up to that. Whereas in case of now, because program counter is one of the identification that how much it can address. Okay, so there is a high, low, and upper. So there are 3 cores in the program counter of the PIC controller. Where therefore, as a result, you will see that it can go up to 2 to the power 21. So 2 to the power 20 is 1 megabyte, and 2 to the power 21 is 2 megabytes. So it will offer you very high ROM. Okay. So therefore, these computing needs are very well taken care by the PIC controller. And RAM, you will see that normally your 8051 gives you 256 bytes, okay, or 128 bytes or 256 bytes. That is the minimum that is available in most of the controllers. Whereas in PIC, like one of the series that we'll see, PIC 18, it offers you as high as 4 kilobytes of RAM, okay, 4 kilobytes of RAM. And IO pins, you have a variety of, starting from port A to port K, port A, B, C, D. In case of PIC, it will not say port 1, 2, 3. They refer the nomenclature port A, B, C, D, like that. So we'll see it when we'll see the pin count and its architecture. We'll get to know that how it what nomenclature is being used. So a lot of pin counts are also available, and timers, of course, these are there more than what we have in our 8051. Then upgrade to high performance. Besides having the on-chip capabilities, it has a capability because of the additional port pins, because of the additional this program counter addressability and address lines available, separate data and program buses for exchanging the data as well as the instruction sets. So as a result, it has got a high upgradability performance also available in it. And software development tools, there are software development tools like MPLab is there, then MPLab ID, which is integrated development environment, so which allows you for all assembler, debugging, compilation, all these features are there. Then there is a in-circuit debugger also, ICD, they call it ICD. And now recently there are many more like PIC 2, and there is one more also. So in-circuit debugger, they call MPLab ICD. So all those development tools are available. And availability and source, which is very widely made available as far as the PIC goes. Very good, excellent technical support and sources are available for the PIC controllers. So therefore, I think one can easily choose PIC controller over the other controllers because of all these characteristics and features. Now we will see little bit about the overview of PIC 18 family. Okay. So coming to the history first, in 1989, Microchip Technology Corporation introduced the 8-bit microcontroller called PIC. At that, during those days, only Atmel or this year 8051, Intel's 8051 was most popular. You can say 8051 was the most popular in the microcontrollers world. Whereas when they launched the PIC 1989, the PIC peripheral interface controller, that was 8-bit chip, and this PIC, it had small amount of ROM, small amount of RAM, and one timer only, and few input-output lines, and all that was packaged in a small footprint and 8-pin chip packet. The footprint was just the 8-pin chip. So you can imagine with the 8 pins. I think 2 lines are going to your power, ground, and VCC. Now what is left out is only 6 pins. So in that you are getting a lot of RAM, lot of ROM, then timer, and few input-output lines. It was just 8-pin small footprint package, and which was not available at that time from any other manufacturers because your Intel's was 40-pin. So this was making a very good job for small applications wherein your requirement is just small controlling some control, because peripheral interface controllers, so it was made for controlling some peripherals. So with 6 lines you can easily control many number of peripherals. Okay, then and now as a result, it was so popular and so powerful in a small compact footprint that it got a wide publicity. And as of now, in microcontroller world, PIC is the most sort of, you can say, world #1 supplier for 8-bit microcontrollers. As far as because today also people prefer 8-bit microcontroller over any other bit family like 32-bit or 16-bit, because most of your applications are getting covered using just 8-bit controllers. There may be pin count of 40 pins or 100 pins, but 8-bit is what the maximum your bandwidth which is used, and is mostly sufficient for complying all the requirements. So as of now, PIC has been identified as one of the most leading #1 supplier in the 8-bit microcontroller family, even higher to your Atmel or any other Philips, because of its vast and very enriched features that it possesses. Then after PIC 16, they introduced array of 8-bit family. A lot of families they introduced. Initially, they launched this PIC 16, okay, and their family includes 10, 10x, 12x, 14x, 16x, 17x, and 18x. These are the series of controllers they launch, and the series starts with 10, 12, 14, and they have different count actually, word count. So that we'll shortly know that what differs in this. And these are all basically all 8-bit. So what we'll be seeing today is just the 8-bit only. And the only problem with them is that they're not upward compatible. For example, your 12x family or 16x family, they have 12 and 14-bit wide. Their word count is 12 or 14-bit wide. Okay. For example, your ROM. Okay, that means its storage. It uses 14-bit count. I'll explain when I'll explain the memory structure. There we'll understand this 14-bit wide, 12-bit wide. Because in case of Intel 8051, it is 8-bit word. Okay, that is that is used for data exchange or code exchange, instruction exchange or data exchange in RAM. Whereas you will see that in case of PIC, it is different. It uses the 16-bit wide or 14-bit wide word count. Okay, and the problem is now this particular 12x or 16x, they are not initially upward compatible. That means if you write a code for one family, lower family, 12x family, then it's the code is not compatible with the 16x family. You'll have to change. But whereas in higher families like PIC 18x, they have code compatibility also, upward compatibility also. And this is the highest performance amongst 8-bit families. As I said, it starts from 10x onwards up till 18x. So there is a lot of series, and this triple X that you are seeing, 10 triple X, 12 triple X, actually it varies. What matters in that triple X, what varies is actually amount of memory available into it, or amount of pin counts available, input output pin counts available. So accordingly, this, the family is changing. Within 10 also there are number of controllers available. So okay, and PIC 18 is actually 16 bits wide. That means 2 byte, as I was telling you. And as a result, the data fetching, like it is like a bandwidth. You know, when you have 2 bytes, okay, 16-bit wide word count. So you are obviously fetching up the data from ROM. It will be quicker. So therefore the speed, and therefore the instruction set bus is separate in case of PIC, and so it is fetching. That machine cycle is quite fast. The performance is fast in case of PIC 18 family. So it is 16-bit wide, and it is the highest performance amongst all 8-bit families. The word count is 2 bytes wide. So you'll see when we see that ROM structure where the instructions are stored, the program is stored, the fetching happens. It is a 2 byte wide. So at a time, 2 bytes are fetched from there. So machine cycle is quicker and faster. So this is just a simplified view of PIC microcontroller. You can relate it with the 8051 family. What you can see, notice the difference over here is your data bus, okay, which is a 8-bit data bus, okay, and that is getting connected to all the peripherals, your RAM, EEPROM, because there is a variety of memories available in PIC. Besides your ROM, there is EEPROM also, and not that all will have, but PIC 18 family is having it. Okay, EEPROM is there to store your some variables permanently. For example, yesterday I was quoting an example that there are few variables. Let's say you're operating your TV and your controller through your TV you're operating. So when you change the channels and all that, your remote, through your remote, when you are doing those operations, sometimes there is a preset, some preset adjustments. So you are storing some preset settings, so that will be always available to you. So when you recall your menus, so that memory, who is doing that job is actually performed by EEPROM. So it stores, it is not non-volatile memory. So unlike your RAM, which is a volatile, which is a SRAM based, static RAM based architecture, your RAM, which comprises your general purpose registers and special function registers, file page registers. That unlike your SRAM, which is volatile, EEPROM is not volatile. So your even the power is off, your some memories, some variables are stored over there. So you can see in the architecture that this data bus, this particular bus is connected to the RAM, which is the 8-bit, EEPROM and other peripherals, and even ports. Your ports are also 8 bits here, and timers. So these are all 8-bit this architecture here. So data bus is different here, and what you can and then oscillator is definitely required. Interrupt control logic, these are all separate blocks. So the difference that you will notice over here is that program bus, your instruction set bus, as I was telling you, that 2 byte wide. Okay, so 16 bits wide. So 2 byte wide, this your data it can fetch. Okay, your instructions it can fetch from the ROM memory. So your program bus, instruction set bus is separate other than your data bus. So there are 2 buses. So what I was telling you is that in case of PIC controllers, it has a RISC architecture as well as it has a hardware architecture. There are 2 architectures, as you know. In case of software, there is a RISC, that is reduced instruction set computers, and complex instruction set computers. And in case of hardware, you are having von Neumann or Princeton architecture and your Harvard architecture. So what happens in this Harvard architecture is that, which is the case in case of PIC controller, that there is a separate data and instruction set buses. So there are separate buses to fetch your RAM memory and ROM memory. They are not a single or common bus systems. So through common bus system, which is a case of the von Neumann or Princeton architecture. So common bus system is not there. In case of PIC, there is separate data buses, instruction set buses, and as a result of which the performance is very good. So RISC then supplemented with this Harvard, it gives a very good architecture and fast this thing. So this is the major difference that you can take note of, that there are 2 buses, one for instruction set, another for your data. Okay, so these are 2 different buses which are made available, and so it is based on the Harvard architecture, and therefore there is a good performance. Now, as far as the pin count goes, this PIC 18 family, which is the most powerful family of the PIC controller, it starts with the 18 pin count to 80 pin package. So you know well how it matters, because when you are developing some particular embedded system application, you have to see that how many number of pins or peripheral input output pin numbers are available. So because these are actually finally connected to your peripheral devices. So in PIC you have wide variety of the pins and input output pins available, ports available, starting from 18 to 80 pin packages. So it is ideal, therefore it is ideal choice, as it allows easy migration also. Okay, if you have if you go for the development of your product using the PIC 18 family, and let's say initially you have developed it for some small application which may not be that complicated, so you may be using, let's say, 18 pin package, and then if you are shifting to higher package, okay, because your application now demands higher power or higher resources, so you can definitely go for up to 80 pin package, and this code is compatible. There is upward compatibility. Okay, so if you select even replace it, this is particularly possible in case of PIC 18 family. So if you shift to a 40 pin or 80 pin, not much will change, except that obviously some pin numbers you have to change, but at large this code is compatible, and therefore people prefer this, and therefore we say that it is the ideal choice as far as the migration goes. So, and one important point is that, as I was telling, that there are different families and series in PIC, like low range, mid range, and high end range. So it's starting from 10x, 12x, 14x, 18x. So if we understand today, mostly I have picked 18 series family. So if we understand a little bit on this, almost you can work with all other series also. So they are almost same. Okay. Now we'll see a little bit about what are the specific features. Okay, PIC 18 features. Because today our interest is only just to touch upon important some basics and some understanding about the PIC family. And PIC 18 features, as I was telling you, architecture wise it differs from your 8051. So mostly we'll try to, in contrast to your basic Intel's 8051, which most of us are familiar with, It contrasts in terms of the architecture, like it has a RISC, it has a Harvard and pipelining architecture, which makes it very, very powerful as far as the performance goes. And as a result, then there are so many features also available to this. Okay. Okay. So you can take note of this, that the feature includes like RISC architecture, and we have already been aware that what is RISC, reduced instruction set computer, and it means that it uses very simple and easy to efficient instruction set. Like every instruction is almost completed in one machine cycle, and you know well this machine cycle relates to the speed and performance of the controller. Therefore, this RISC, they use just 32 or 35 instructions as compared to more than 100 instructions in case of 8051. So RISC architecture, that is what we get advantage compared to the CISC architecture. And then on-chip ROM. Okay, there is an on-chip ROM, that is a code memory, and that can go as high as 2 megabytes. So I was telling that the program counter of the PIC controller is 2 to the power 21. That much wide it has. Okay, so 2 to the power 20 is 1 megabyte. So program counter is one of the indicator that how much address it can access. If your program counter is 2 to the power 21 wide, so that means it can go up to 2 megabytes. Okay, that means there are 8-bit, so 2 to the power 21, it can access the address. Okay, because to access your data, what you need is actually address, whether data or code. So what you need is firstly the address. When you address that thing, then you can access that thing. So particularly in case of PIC family, the program counter is 21-bit wide. Okay, so the on-chip memory, it can go from as small as some kilobytes to 2 megabytes. And of course, on-chip memory code is available up to 128 kilobytes in case of PIC 18, but it has a scalability up to 2 megabytes. And when it comes to developing embedded system, this thing matters. Okay, that how much memory we can connect to the particular controller, unlike your general purpose x86 based general purpose embedded system, wherein you have all the flexibility of adding the blocks as many as you want. But in case of select microcontrollers, you have limitations that once you select, it remains fixed. So therefore, if you select a PIC 18 family, your ROM can go up to 2 megabytes because of the inherent capabilities. And RAM also, once again, you know, in case of 8051, RAM के केस में कितना हमारा होता है 128 bytes, 256 byte. So maximum इस तरह से हमें इंटेल्स की है, एटमेल्स की इतना मिलता है कि 256 होता है, जैसे इंटेल्स में 8051 में 128 bytes है. So, and mostly these 128 bytes are consumed by your special function registers, which are mainly used for controlling your peripherals, okay, on-chip peripherals like timer, counter, serial ports, etc. So, whereas in case of now PIC, you will see that it has got 4 kilobytes of RAM, okay, and out of them, obviously, 256 bytes are reserved for your special function registers. So there are two in RAM, you know, RAM space, there are two basically registers. One is SFRs and other is GPRs, so general purpose registers. So the file registers of the RAM comprises of general purpose registers and special function registers. So every controller will have special function registers for sure. Your general purpose register memory may be restricted. So 128 bytes तो होते ही होते हैं special function registers के लिए. Remaining 128 bytes are used for generally for scratch pad or working surface or working area. Okay, something like that. So, but in case of PIC, you have large, wide variety and wide space, working space, scratch pad available. So we'll see that, and they have divided it in terms of banks. So they are divided like 4 kilobytes का आपका जो है, they have divided, each bank is of 256 bytes in case of PIC. 256 bytes का एक bank होता है इसमें. So they have almost 16 banks. So 256 bytes का एक बैंक, तो 16 banks इसमें RAM के होते हैं 4 kilobytes के. So you can address them or use them. And then there are special bits. 3 bits are there to have addressability, कौन सी bank access करना है. So when we will see the RAM memory structure, वहाँ पर आप देख सकते हैं कि कैसा है वो. Then data square PROM भी है. So क्या चीज? 16 banks है. RAM में एक बैंक, हाँ, 2 to the power 4. Yeah, 16 banks, 2 or 3 or 4. I mean, depending upon the family that you are using, because in every PIC family you will not have 4 kilobytes. So PIC 18 also you don't have complete 4K available for all the series, but in general I am saying that is the maximum you can have. Maximum you can have 4 kilobytes, and then some family will have some number of banks available, 2 banks or 3 banks, not that all the 16 banks, but total maximum you can have 16 bank. So, and okay, then timers are there, ADC, USART, and input output ports. Okay, then other features include size. Okay, size. So as far as that goes of the architecture, then on chip kya hai, then size of ROM, RAM, data square PROM, and IO ports. This varies. This varies among family. That's what I was telling, that this will vary among the family, but all have peripherals. Peripherals सब में रहेगा. आपका RAM, ROM और जो pin है, input output pins, that will vary. Mainly आपका memory vary होगा और ports vary होंगे. But the peripherals say ADC, USART, timers, these are common to all the family members. Okay. This is not very clear to you, but I'll just try to tell few things, then we'll move forward, because बाद में और अच्छे थोड़े कुछ figures है independent. तो इसमें mainly what you can see, there are ports from port A to port G8, मतलब unlike your 8051 port 1 2 3 नहीं बोलते, इसमें port A से शुरू होता है, A B C D alphabetically they call it port A B C D E F like that. So there are 8 ports in highest family, and then unlike your again 8051, it's not that the whole ports are symmetrical कि बे सब में 8 bits ही है. किसी में आपको देखेंगे 4-5 bits भी है, जैसे फॉर एग्जांपल पोर्ट ए है, इसमें आपका 3 4 5 6 7 है ओनली. ओके, सो 7 बिट्स यहाँ पर अवेलेबल है. देन पोर्ट बी में ओनली 2 3 4 5 बिट्स अवेलेबल है. सो लाइक दैट. सो दिस इज पर्टिकुलरली मेनी ऑफ दिस इज मल्टीप्लेक्स. अच्छा, तो this is so far as the ports goes. Okay, then there are data, and then there is यहाँ पर ROM. So main difference that you can take note of, जैसे पहले मैंने simplified एक architecture दिखाया था starting में, कि there is a separate bus. Okay, there is a separate data bus, separate instruction set bus. So data के लिए separate bus है आपका 8 bit का, and instructions के लिए जो है यहाँ पर 16 bit ROM जो है, ROM का bus जो है 16 bit wide है. What I am showing here is a 16 bit wide ROM bus, जिसमें कि 2 megabytes तक का आप मेमोरी डाल सकते हैं. And then instruction जो आपका इधर data वाला जो है RAM वाला, that is 8 bit. And which is connected to other things also, like your ports. So SFR also 8 bit. So that is important thing to take note of. And बाद में आपके timer counter ये सब 8 bit ही है. Rest all is you can see that 8 bit data bus जो है, because this is a Harvard architecture. So there are 2 separate buses now to access your both the memories. तो ये देख रहे होंगे यहाँ पर आप 8 bit bus जो है, normally आपके सभी SFR, RAM और इन सब including ports also, इन सबको SFR जितने भी है आपके include timer, counters, ports, इन सब के साथ में 8 बिट डेटा बस कनेक्टेड है. और 16 बिट जो है बस वो सिर्फ प्रोग्राम मेमोरी के लिए है. तो वहां से आपका फेचिंग जो है मशीन साइकिल बहुत फास्ट हो रहा है, बिकॉज 2 बाइट्स आर गेटिंग फेच्ड एट ए टाइम. एंड देन बाकी तो ऑसिलेटर है, जैसे नॉर्मल ऑसिलेटर्स होते हैं हमारे, इसमें ऑसिलेटर पिंस दिखाई गई है, देन रीसेट पिंस है, एंड रेस्ट ऑल इज नथिंग न्यू इन दिस, रेस्ट ऑल इज सेम. एंड यू नो हार्डवेयर का कॉस्ट कम कर दिया या कॉम्प्लेक्सिटी कम कर दी, तो क्या है, सॉफ्टवेयर का लोड बढ़ा दिया है, बिकॉज मोस्ट ऑफ द पिंस आर ड्यूअल फंक्शन. लाइक इसमें पोर्ट्स का इनपुट आउटपुट जनरल पर्पस है, एट द सेम टाइम इंटरप्ट्स या टाइमर्स, ये पिंस भी इसी के ऊपर जा रही है. जैसे पोर्ट भी है, आप देखो इसमें इंटरप्ट भी है, इंटरप्ट 0 1 2, ठीक है. देन इस तरह से कुछ मल्टीप्लेक्स पिंस है. ओके, सो दिस इज अगेन अनदर टाइप. ओके, now we'll see about PIC microcontroller program ROM code. The program memory जो है, which is a read only memory, which is a code memory, we can call code memory also, जहाँ पर program store किया जाता है. So we'll see little bit about that. PIC microcontroller program ROM code. This we already know that it is used for storing the program. And it can have, as I have been saying, that it can have 2 megabytes of ROM space, but it is not installed. Okay, but it is not available on chip for all the controllers. That is extendable, that can go up to that, because of what reason I told you already. And ROM size varies, okay, from 4 to 128K. ROM का भी जो maximum 4K, बट एक देखिए कि आप स्टिल 128 बाइट से नहीं शुरू हो रहा है, 4K से शुरू हो रहा है इनके सब PIC 18 फैमिली, एंड 4K से लेके आपका 128 किलोबाइट तक रॉम जा रहा है. सॉरी अबाउट रॉम जो मैं बात कर रहा था. सो रॉम यहाँ तक आपको ऑन चिप अवेलेबल है, विच डिपेंड्स अपॉन द फैमिली दैट यू आर चूजिंग. और आपके 8051 में 4K होता है, ठीक है ना, और वेयर एज इनके सब PIC व्हाट यू हैव इज अप टू 128K. So it is a huge memory available, we can say, and almost most of the complicated applications से develop हो जाते हैं without any issues, memory issues. And ROM type जो है different types के available है, flash, one time programmable and masked, and all have different part numbers. तो flash क्या होता है ना, आपका electrically erasable जैसे होता है. one time programmable, एक बार प्रोग्राम करने के बाद बार बार उसको प्रोग्राम नहीं कर सकते. अब ये कब यूज करते हैं? सो द डिफरेंस इज बेसिकली व्हेन वी आर इन द डेवलपमेंट साइकिल, आप कोई प्रोडक्ट डेवलप कर रहे हो तो एट दैट टाइम आपको फ्लैश मेमोरी वाला आप यूज करते हो. यस, एंड वंस योर दैट डेवलपमेंट इज कंप्लीटेड, देन व्हाट यू कैन डू इज कि वन टाइम प्रोग्रामेबल, उसको उस टाइप का एक वर्जन आप खरीद सकते हैं. PIC में दिस फैसिलिटीज अवेलेबल कि उसको आपका कोड डेवलप है, प्रोडक्ट फाइनल हो गया तो आपका कोड अब OTP में डाल दिया, दैट इज वन टाइम प्रोग्रामेबल. तो इसका एडवांटेज क्या है? लेट अस अंडरस्टैंड दैट आल्सो. कि आपने डेवलपमेंट के टाइम पे तो फ्लैश वाली यूज कर लिया है, ठीक है, आपका डेवलपमेंट प्रोडक्ट डेवलप हो गया, नाउ यू आर स्विचिंग टू द OTP बेस. तो एडवांटेज इज दैट ये मेमोरी दिस द कॉस्ट वेरीज, फ्लैश वाला कॉस्ट मोर, ठीक है. तो इसलिए OTP वाला जो है इट विल कॉस्ट वेरी लेस, बिकॉज वंस नाउ योर प्रोडक्ट इज डेवलप तो OTP में आपने अपने बस प्रोडक्ट में लगाना ही है चिप को, सो इट विल कॉस्ट लेस. एंड दिस वन मोर नाउ, मास्क्ड, ठीक है. ये मास्क क्या है? ये जो चीज है डायरेक्टली फैक्ट्री प्रोग्राम्ड आएगी. आपने अगर कोड बता दिया और ऑर्डर दे दिया कि मुझे 1,00,000 यूनिट या 1,000 यूनिट चाहिए, तो मास्क करके दे देंगे और वो पर्टिकुलर प्रोग्राम का. दैट इज इवन मच मोर चीपर नाउ, मोर चीपर इवन OTP से भी कम इसका प्राइस करेगा. सो जब बल्क वॉल्यूम मैन्युफैक्चरिंग होता है तो पीपल गो फॉर द मास्क्ड वर्जन्स, एंड दे ऑल हैव डिफरेंट पार्ट नंबर्स ऑब्वियसली. Okay, now although different speed and amount is available, they are compatible as far as the instructions are concerned. So they have different speed and amounts of this ROM RAM, but they are code compatible in case of PIC 18 family, which was not the case with PIC 12 series and low or mid range वाले में problem थी, upward compatibility नहीं था, but 18 में ये compatibility है. Instructions are concerned, instructions are common. Okay, ROM type से ही हमने अभी देखे अभी कि जैसे PIC ROM types, PIC microcontroller with UEEPROM. तो PIC जो है आपको UEEPROM बेस भी पहले अवेलेबल था, बट आई थिंक दिस डेज नोबडी इज यूजिंग इट. अर्लियर लाइक उसके अंदर मेन उसका क्या था कि PIC का कोई पार्ट देखोगे उसकी आइडेंटिटी ये थी कि उसके टॉप पे एक विंडो होता था, ऐसे क्वार्ट्ज क्रिस्टल वाला विंडो, और इट यूज्ड टू यूज द EEPROM फॉर ऑन-चिप ROM, ठीक है. ऑन-चिप उसके अंदर EEPROM होता था बिकॉज इरेजेबल प्रोग्रामेबल रीड ओनली मेमोरी, यू कैन इरेज इट एंड प्रोग्राम इट. ओके, एंड UV तो एंड नीड्स बर्नर एंड इरेजर, इसके लिए आपको बर्नर भी चाहिए था, ठीक है, प्रोग्रामर, और इरेजर भी चाहिए था. एक UV का एक छोटा सा एक आपने, आई डोंट नो वेदर यू हैव सीन इट नॉट, UV का एक इरेजर आता था जिसके अंदर हम वो जो है ना विंडो एक्सपोज करके रख देते थे और फिर उसको 30 मिनट्स रखना पड़ता था और वो इरेज होके देन यू कैन यूज इट, रीयूज इट. सो विंडो अलाउज UV लाइट टू इरेज, जैसे विंडो की बात, टेक 20 मिनट्स टू इरेज. फ्लैश इज रिप्लेसिंग UEEPROM. सो ऑलमोस्ट नाउ ये पूरा फर्स्ट वाला वर्जन जो है PIC वाला, ये रिप्लेस हो गया है विद द फ्लैश वर्जन. नाउ इफ यू कम टू द PIC 18F, सो देयरफॉर इसका जो F जो है ना, F स्टैंड्स फॉर फ्लैश. सो PIC 18F XXX विद फ्लैश, दैट मीन्स लेट्स से फॉर एग्जांपल PIC 18F 458 एक सीरीज है कोई, ठीक है, इसमें आपको फ्लैश वाला पता चल गया कि फ्लैश है, इसमें फ्लैश यूज होगा एज ऑन चिप ROM, ठीक है. तो इसकी जो मेमोरी रीड आपको राइट करोगे और मतलब प्रोग्राम डेवलपमेंट के वक्त, सो इट विल फ्लैश, मतलब इसमें बर्नर तो चाहिए होगा, अभी भी आपको बर्नर चाहिए, ठीक है, बट वो जो इरेजर है, इरेजर का आप जरूरत नहीं है बिकॉज इट विल बी इलेक्ट्रिकली नाउ. सो आइडियल फॉर फास्ट डेवलपमेंट. सो yesterday also I was quoting this example जिसमें आपको UV बेस इरेजिंग करना पड़ रहा है, 20 मिनट्स लग रहे हैं हर एक टाइम पे. सो कंपेरेटिवली आपका आइडियल फॉर फास्ट डेवलपमेंट, और नीड्स बर्नर बट नो नॉट इरेजर, ठीक है, क्योंकि इसके प्रॉम है कि इसमें आपको इरेजर की जरूरत नहीं पड़ेगी. एंड मस्ट इरेज एंटायर ROM. इसमें ये कि ब्लॉक वाइज आप कर सकते हो, दिस इज डिफरेंस. एक कुछ आते थे कि आप ब्लॉक वाइज भी उसको इरेज कर सकते हो, इसमें इलेक्ट्रिकल इरेजर में ये है कि आपको पूरा ही इरेज करना पड़ेगा, यानी कि पर्टिकुलर ब्लॉक इरेज कर दिया. And can be programmed or erased using PIC-Kit2 from microchip via USB port और IBM PC. PIC-Kit2 एक डेवलपमेंट किट और उसका एक प्रोग्रामर है. बेसिकली PIC-Kit2 एक प्रोग्रामर है जो कि आपका माइक्रो कंट्रोलर के PIC-Kit थ्रू will connect to the controller kit and PIC-Kit through again will connect to the computer environment IDE. So इसके थ्रू आप उसको प्रोग्राम करोगे, इरेज करोगे. So PIC-Kit2 ये जो है MP लैब माइक्रोचिप टेक्नोलॉजी से अवेलेबल है. एंड बट दिस इज ICD मेरे ख्याल से इसमें नहीं है. दिस इज अगेन ओनली प्रोग्रामिंग. अगर आपको इन सर्किट डीबगिंग करनी है तो आप ICD वर्जन लेना पड़ेगा, उसमें डीबगिंग भी हो जाएगा. सो आइदर ऑफ दिस मोस्ट लाइकली इसमें शायद होना चाहिए. तो इन सर्किट डीबगिंग, बिकॉज इफ समथिंग इज नॉट वर्किंग यू कैन रियल टाइम में यू कैन चेक. सो दैट फैसिलिटी, तो आपको विंडो के अंदर ही पता चल जाएंगे सभी रजिस्टर्स के क्या स्टेटस वगैरह वगैरह है. एंड while it is working, so you can check. So that is real time debugging, you can see. Yeah.
Our pen drives are flash memory, right? So we don't need to erase all of it in order to replace the data. So there is certain that we must erase entire ROM. But in case of EEPROM, it's not valid, I guess.
In pen drive itself is an embedded system. Pen drive is not only memory. It's not only EEPROM or flash memory. It has flash and there is a microcontroller inside that residing it.
That is the driver circuitry that is used for accessing that.
Yes. So there is a flash memory and there is a controller and complete driver and all that electronics. So pen drives itself are a complete embedded system. So that controller, what it does, it allows you, when your computer, when you say delete only that much, so it allows you to actually erase that particular block or particular file. So there is a pen drive itself is a complete, don't treat that as just a flash memory. It is a flash memory and interface with the controller. It is an embedded system in itself. तो मेमोरी नहीं, ओनली मेमोरी नहीं है, उसके अंदर कंट्रोलर लगा हुआ है. वो कंट्रोलर को कस्टमाइज किया गया कि ऐसे सब फंक्शनलिटी करना है. दिस इज ओनली फॉर कंट्रोलर. पिक कंट्रोलर का जो आर्किटेक्चर है, यहाँ पर आपको फ्लैश में पूरा इरेज करना पड़ेगा. इसमें मतलब ब्लॉक वाइज नहीं आपको, क्योंकि जो पिक वाला है इसमें हमने ऐसा कोई कस्टमाइज प्रोग्राम अंदर रखा नहीं है ना.
There you can give an electric pulse and you can raise a block of memory, not entire memory, because you have got rows and columns there, right? And you can raise a row entirely, not all the rows.
वो EEPROM है ना, ये जो फ्लैश की बात कर रहा हूं मैं, फ्लैश पिक 18 का जो फ्लैश मेमोरी है, बस इसमें करना है. ये जो पिक का हम जिसको रॉम बोल रहे हैं, रॉम पिक का रॉम की बात करें, उसमें करना है. EEPROM इज अनदर एडिशनल मेमोरी अवेलेबल, ठीक है. तो बट इट इज इलेक्ट्रिकली इरेजेबल है ना. एक EEPROM आता है हम जो एडिशनली लगाते हैं, छोटी सी 8 पिन का चिप भी आता है. EEPROM जो है इसके अंदर भी मिलता है, पिक के अंदर भी एक EEPROM का सेपरेट ब्लॉक है जिसको हम कस्टमाइज वे में कर सकते हैं. कुछ वेरिएबल हमारे स्टोर भी कर सकते हैं. लेकिन जो प्रोग्राम मेमोरी है रॉम, जो कि अगेन फ्लैश बेस्ड ही है, टेक्नोलॉजी दोनों की फ्लैश बेस्ड है, लेकिन ये जो रॉम रहेगा, रॉम वाला ब्लॉक आपको पूरा करना पड़ेगा. इसमें उन्होंने कोई वेक्टर वाइज सेगमेंटेशन नहीं की कि ये वेक्टर आपका ऐसा करेगा. EEPROM में आप कर सकते हो, उसके अलग अलग मतलब आर्किटेक्चर है.
ठीक है सर. और जो ये हमारे पास लिखा है नीड बर्नर बट नॉट इरेजर, राइट, बट आई थिंक सो दैट बर्नर itself does the erasing first, then it runs.
हाँ, that is why this is in the context जो पहला जैसे है ना, पहला UV EEPROM था. इन द कंटेक्स्ट ऑफ फर्स्ट पिक वाला जो है जिसके अंदर आपका UV EEPROM है, which is not a EEPROM. तो वो सिर्फ EEPROM जहां पर है उसके लिए आपको बर्नर इरेजर भी चाहिए था, जो UV इरेजर चाहिए था, है ना. इन दैट कंटेक्स्ट सेकंड इसमें सिंस इट इज अ फ्लैश, तो इसमें ये कहा गया कि आपको इरेजर नहीं चाहिए होगा. जैसे पहले इसमें आपका सिर्फ EEPROM था, अभी EEPROM है. EEPROM है इसीलिए इसमें आपको इरेजर की जरूरत नहीं, क्योंकि ये यूवी बेस्ड टेक्नोलॉजी तो है नहीं है, इलेक्ट्रिकली इरेजेबल है. एक पल्स दिया, इलेक्ट्रिकल पल्स गया, उसने इरेज कर दिया. इट इज इन दैट कंटेक्स्ट. ऑब्वियसली एज यू आर सेइंग इज सेम थिंग, व्हाट यू आर सेइंग इज करेक्ट कि भाई इलेक्ट्रिकली इरेजेबल है, तो इसमें इरेजर का जरूरत ही नहीं है, इजंट इट? व्हाट यू आर सेइंग इलेक्ट्रिकली इरेजेबल है ना, तभी नहीं चाहिए. You are correctly saying it. That is what is mentioned. Same thing. What is mentioned is same thing. What you are meaning ना, same thing it is meaning कि ये इलेक्ट्रिकली इरेजेबल है, इसलिए इसको इरेजर का जरूरत नहीं है. Unlike your UV EEPROM जिसमें इरेजर लगेगा. Same thing. We are saying both of us are saying same thing actually. Okay. Then OTP वर्जन का जैसे मैंने बताया था कि आपको जैसे इसका एग्जांपल भी दिया है PIC 16C. Now you will see इसमें F नहीं है, ठीक है, इसमें C लिखा हुआ है. So ये OTP वर्जन हो गया, ठीक है. कि OTP वर्जन अवेलेबल फ्रॉम माइक्रोचिप, कहने का मतलब है पिक फैमिली जो माइक्रोचिप से अवेलेबल है, इसमें इरेजर वाली फैमिली अवेलेबल है, यूवी EEPROM वाली है विच इज नॉट नो मोर यूज दिस डेज, एंड देन आपको OTP वाला भी अवेलेबल है, एंड लेटर सी इंडिकेट्स OTP ROM वर्जन. और OTP, और देखो मास्क में और OTP में डिफरेंस क्या है. OTP वाला क्या है, यू कैन प्रोग्राम इट योरसेल्फ. OTP वाले में C आपको आएगा नॉमेनक्लेचर रख के, वो आप खुद ही प्रोग्राम कर सकते हैं, लेकिन वन टाइम. वो एक बार प्रोग्राम कर दो फिर भूल जाओगे, ठीक है, आपका डेवलप था पूरा प्रोडक्ट तो आपने उसको प्रोग्राम करके रख दिया. सो दैट इज अ C व्हिच कैन बी डन एट द यूजर एंड, एट द डेवलपर एंड. सो दैट इज द डिफरेंस बिटवीन द फील्ड प्रोग्रामेबल कह लो, मतलब फील्ड प्रोग्रामेबल. अब जैसे फ्लैश भी है, वो फील्ड प्रोग्रामेबल ही है कि आप, लेकिन फ्लैश कब यूज कर रहे हो, डेवलपमेंट के टाइम पे, कि आप कंटिन्यूसली इरेज कर रहे हो, राइट कर रहे हो टिल योर प्रोग्राम गेट्स फाइनलाइज्ड. जब तक फाइनल नहीं हो रहा तब तक उसको कर रहे हो. सो इनके पर्पज अलग अलग है, बट पॉइंट की आपका फ्लैश वाला भी आप यूजर एंड की तरफ ही, डेवलपर जैसे आप डेवलपर हो तो आपके साइड पे आप कर रहे हो, और OTP वाला भी आपके साइड में कर रहे हो. दोनों में डिफरेंस है कि वन टाइम प्रोग्रामेबल है, क्योंकि आपका प्रोग्राम आपने फाइनल कर लिया यूजिंग द इलेक्ट्रिकली इरेजेबल वर्जन. अब आप OTP में एक बार डाल दिया, क्योंकि आप कॉस्ट ऑप्टिमाइजेशन कर रहे हो, क्योंकि पहले आपने जब लिया था यही सीरीज, लेट्स से PIC 16 C 430 C की जगह F था, ये लिया था आपने, तब आपने प्रोग्राम फाइनल कर लिया, आपका प्रोडक्ट अब रेडी हो गया, प्रोडक्ट को आपने मार्केट में लॉन्च करना है. अब आप ऑर्डर करोगे PIC 16 C वाला दे दीजिए हमें, क्योंकि वो 100 रुपए का कॉस्ट कर रहा था, ये आपको 50 रुपए में आएगा, ठीक है. द कॉस्ट डिफरेंस हो गया. फिर अब आपने इसमें यही प्रोग्राम, क्योंकि कोड दोनों के सेम है, प्रोग्राम करके प्रोडक्ट में लॉन्च कर दिया. नाउ दिस यू आर डूइंग एट योर एंड एज फार एज द OTP गोज. नेक्स्ट वर्जन मैंने बताया था मास्क्ड. मास्क वर्जन क्या होगा, वो फैक्ट्री एंड पे होता है, वो आप नहीं कर सकते. वो फैक्ट्री को आप कम्युनिकेट करोगे कि ये मेरा कोड है, उसको मास्क कर देना, वो उसको मास्क कर देंगे. दिस इज द डिफरेंस. ओके, लेटर C इंडिकेट्स. सो नाउ OTP ROM वर्जन, फ्लैश वर्जन इज यूज्ड फॉर डेवलपमेंट. व्हेन एब्सोल्युटली फाइनलाइज, OTP इज यूज्ड. यही मैं कह रहा था कि एक बार फाइनल हो गया तो OTP जो है यूज फॉर मास प्रोडक्शन बिकॉज ऑफ चीपर कॉस्ट, एंड OTP कांट बी रिप्रोग्राम. एंड मास वर्जन ऑफ द PIC Microchip provides service to burn the program during fabrication. और जब fabricate करेंगे, it provides the facility. So this we have to see कि कौन सा कंट्रोल हम सिलेक्ट करेंगे, कौन से मैन्युफैक्चरर्स कैसी फैसिलिटीज प्रोवाइड कर रहे हैं. सो ये फैसिलिटी जो है PIC के केस में अवेलेबल है माइक्रोचिप से, कि आप मास्केबल कंट्रोलर्स आर आल्सो अवेलेबल, ठीक है. दैट विल हैपन एट द टाइम ऑफ फैब्रिकेशन. एंड एज आई सेड कि मास PIC जो है, these are the cheapest of all, even cheaper than the OTP versions. Okay, so this was all about PIC program ROM types. Now we will see about PIC data RAM. Okay, and EEPROM. प्रोग्राम ROM का हमने देखा था कि अभी और प्रोग्राम ROM का आएगा. 16 बिट वाइड है उसका, जो इंस्ट्रक्शन सेट है वहां से फेच करना है. तो जैसे देखो, इट इज लाइक अ हाईवे. एक 8 बिट का हाईवे है, वहां से आप मेमोरी इंस्ट्रक्शंस जो है फेच कर रहे हो, और 8 बिट्स आ रहे हैं. सो ऑब्वियसली इट विल बी टेकिंग कंज्यूमिंग मोर टाइम एज कम्पेयर टू द 16 बिट वाइड, क्योंकि आप हाईवे, आप ब्रॉडबैंड हो गया है. सो एट ए टाइम आपका ज्यादा, और मशीन साइकिल्स भी कम लग रही है. ओके, अभी नाउ वी आर सीइंग अबाउट द रैम, दैट इज अ डेटा मेमोरी. ओके, और रैम जो है मैंने बताया था कि इसमें हार्वर्ड आर्किटेक्चर है PIC में, एंड देयर आर 2 सेपरेट बसेस, इंस्ट्रक्शन बस एंड देन देयर इज अ डेटा बस. इंस्ट्रक्शन सेट फॉर द ROM एंड डेटा बस फॉर द रैम, बट दिस इज 8 बिट. ओके, एंड रैम जैसे फाइल रजिस्टर्स जो होते हैं, इसमें 2 रजिस्टर्स होते हैं, GPR जनरल पर्पस रजिस्टर एंड स्पेशल फंक्शन रजिस्टर्स. स्पेशल फंक्शन रजिस्टर्स आर नॉट कंट्रोलेबल बाय द इंस्ट्रक्टर. आई मीन यू कैन नॉट कंट्रोल इट्स फंक्शनैलिटी. उसकी फंक्शनैलिटी फिक्स है. अगर उसने टाइमर, काउंटर, TCON, SCON, ये जैसे 8051 में होते थे, अगर उसने वो कंट्रोल करना है, टाइमर, काउंटर, तो उसकी आप फंक्शनैलिटी चेंज नहीं कर सकते. वेयरएज जनरल पर्पस रजिस्टर्स जो है, दे आर available to the user or developer for storing the instructions. They are just general scratch pad, okay, wherein you can store. This is the main thing. ओके, नाउ लेट अस सी, रैम इज अ स्पेस फॉर डेटा स्टोरेज। ओके, यहाँ पर आप इंस्ट्रक्शन नहीं स्टोर कर सकते, आप प्रोग्राम नहीं स्टोर कर सकते इसमें। दिस इज अ डेटा स्टोरेज, क्योंकि ये वोलेटाइल मेमोरी है, बिकॉज दिस इज SRAM बेस्ड, स्टैटिक रैम बेस्ड है, वोलेटाइल मेमोरी है। इसमें जो भी आप स्टोर करोगे वो टेम्पररी रहेगा। दिस इज अ टेम्पररी स्क्रैच पैड। ओके, एंड रोम में आप परमानेंट आपका प्रोग्राम रखते हो, क्योंकि आप पावर भी ऑफ हो गया तब भी इट इज देयर, पावर ऑन होते ही वो जो है इट विल एक्टिवेट एंड प्रोग्राम विल स्टार्ट रनिंग। Whereas RAM is not the case, वो always blank हो जाएगा, it is volatile memory. Then PIC 18 has 4 kilobytes of RAM. इसके अंदर 4096 बाइट जो है of RAM available है, that is the highest in case of PIC 18, and of course it will vary with the different family members you select. And all family members varies in RAM size, जैसे 256 बाइट्स मिनिमम, इतना तो सब में, क्योंकि सब में SFR तो होना ही होना है, ठीक है, SFR सब में रहेंगे। सो 256 बाइट जो ये वाला बैंक है, ये बैंक तो सब में होगा, एंड इट कैन गो अप टू 4096 बाइट्स। एंड रैम डेटा स्पेस, अब रैम डेटा स्पेस में क्या क्या होता है? 2 कंपोनेंट्स होते हैं इसके अंदर, एज आई हैव बीन टेलिंग यू, जनरल पर्पस रजिस्टर्स एंड स्पेशल फंक्शन रजिस्टर्स। स्पेशल फंक्शन रजिस्टर्स जैसे आपके पोर्ट्स है, पोर्ट ABCD, ये सब भी उसी में आता है, आपके टाइमर्स, काउंटर्स, सीरियल पोर्ट्स, एंड ऑल दिस कम्स अंडर द स्पेशल फंक्शन रजिस्टर्स। उसके एड्रेसेस भी फिक्स्ड है, एड्रेसेस तो GPR के भी फिक्स्ड है, एंड SFRs are fixed and all microcontroller must have them. स्पेशल फंक्शन रजिस्टर जो है ये फिक्स है, और सभी इररिस्पेक्टिव ऑफ कौन सी फैमिली आप चूज कर रहे हो, सभी माइक्रो कंट्रोलर फैमिलीज में SFR तो होगा ही होगा, ठीक है। और बिकॉज दे आर एसोसिएटेड विद द पेरिफेरल्स, जो ऑन चिप पेरिफेरल्स है आपके टाइमर काउंटर, क्योंकि एज आई वाज टेलिंग कि आपकी इनपुट आउटपुट बिट चेंज हो जाती है जब फैमिली चेंज होती है, और आपकी मेमोरी स्पेस चेंज हो जाती है, लेकिन आपके ऑन चिप पेरिफेरल्स ये सभी में है। तो सिमिलरली देयरफॉर आपके SFRs जो है फिक्स्ड है ऑल माइक्रो कंट्रोलर्स के लिए, एंड दे मस्ट हैव देम। और GPR जो साइज जो है ये वैरी होगा। तो आप जब मैन्युफैक्चरर्स की वेबसाइट पे जाओगे तो आप देखोगे कि ये जो साइज वैरी होगा ना रैम का, ये GPR का साइज होगा, जनरल पर्पस रजिस्टर का, कि किसी में लेस देन 4K है या 1K है या 2K है, लाइक दैट। तो दैट इज द GPR साइज, नॉट SFR साइज। SFRs आर फिक्स्ड, so GPR size vary chip to chip, thus microchip website gives GPR size only. And RAM जो है again RAM में जो GPR space is used for read write and scratch pad data manipulation and is divided into 2 banks, into banks up to 56 bytes each. ये mainly जैसे SFR आपके associated है, जैसे टाइमर काउंटर रजिस्टर, सीरियल कम्युनिकेशन रजिस्टर, SCONs, और बहुत सारे 8051 के जैसे होते हैं, TCON, SCON, SMOD, all these TMOD, टाइमर मोड कंट्रोल रजिस्टर्स। तो ये जितने भी पेरिफेरल्स है, अब जैसे आपका सीरियल कम्युनिकेशन है तो SCON, SMOD, these are related to that. टाइमर काउंटर है TCON, PCON, ठीक है। TMOD मोड से आपको, TMOD से आपके मोड डिसाइड होते हैं, टाइमर कंट्रोल से आप रन स्टॉप ये सब करते हो TCON से। सो तो वो उसके लिए है। तो GPR जो है ये रीड राइट स्क्रैच पैड है। यहाँ पर आपके कोई टेम्पररी आप स्टोरेज जो है मैनिपुलेशन जब करते हो तब वो स्टोरेज होता है। स्टैटिक मेमोरीज होती है, स्टैटिक वेरिएबल्स होते हैं आपके प्रोग्राम में जो जनरेट होते हैं, आप या यूज करते हो उसके लिए, एंड दे आर डिवाइड इनटू बैंक्स। अब जब हम इसका मेमोरी आर्किटेक्चर देखेंगे वहां पर पिक्टोरियल भी दिखेगा कि कैसे होता है। ओके, अच्छा, कुछ फैमिली में स्मॉल अमाउंट ऑफ EEPROM भी है, ठीक है, इलेक्ट्रिकल प्रोग्रामेबल रीड ओनली मेमोरी। अनलाइक फ्लैश जैसे आपका कोड स्टोर करने के लिए यूज होता है, ये स्क्वेयर जो प्रॉम है, ऑल्दो टेक्नोलॉजिकल वाइज दे आर ऑलमोस्ट सिमिलर, बट ये पर्टिकुलर जो कोर है ये आपके वेरिएबल स्टोर करने के लिए, कुछ वेरिएबल्स आप अगर उसमें स्टोर करना चाहते हो, जैसे मैं रिमोट का ऑफन आई गिव, कुछ प्री सेटिंग्स जो है, प्री सेटिंग्स वहां पर स्टोर होगी। क्रिटिकल डेटा नॉट चेंज वेरी ऑफन, ये जो क्रिटिकल डेटा, और ये रीराइट भी होगा। रॉम जो एक बार प्रोग्राम फिक्स कर दिया तो वही हो गया, बट रॉम के प्रोग्रामिंग के थ्रू ही आप एक पर्टिकुलर EEPROM की ऐसी प्रोग्रामिंग हो सकती है कि यू कैन चेंज सम प्री सेटिंग्स। कोई जैसे एग्जांपल उसी का ले रहा था मैं, रिमोट जो है आपका टीवी का, तो सडन थिंग्स प्री सेटिंग जो है आप फिक्स रखते हो कि ये आपके मोबाइल में भी आप कुछ अलार्म लगा के रखते हो, और कुछ देयर आर प्री सेटिंग्स एंड यू वांट देम टू बी ऑलवेज अवेलेबल, सो दोस थिंग्स आर कस्टमाइज्ड। तो वो चीजें ऐसे EEPROM में होती है, दे कैन बी इरेज आल्सो। लेकिन जो एक मेन प्रोग्राम है आपके मोबाइल का, कि जैसे आप ऑन करते हो, जिस तरह से एंड्रॉइड का सिस्टम है, वो तो नहीं चेंज होता, दैट रिमेन्स फिक्स। बट ये जो कुछ टेम्पररी चीजें है जो आप स्टोर करते हो, इरेज करते हो, चेंज करते रहते हो, ये EEPROM वाला एक पर्टिकुलर कोर होता है जहां पर ये सब आप कर रहे हो। Okay, PIC 18 must have some RAM as a scratch pad. Okay, but E square PROM is optional. ये तो optional है, and it has a specific functionality जो होती है. Not all versions of PIC 18 have E square PROM. ठीक है, सभी में E square PROM होना जरूरी नहीं, लेकिन फ्लैश तो सब में होगा ही. ठीक है, ROM मेमोरी सब में होगा. That is compulsory. Okay, और E square PROM is a luxury kind of thing. Okay, additional thing. So इस फैमिली में आप देखोगे कि सम ऑफ द PIC 18, ये जो 18 के फैमिली है, 18 कोड जो है 4K से लेकर 128 के वेरी होता है. हाईएस्ट जो है PIC 1887 वाले में है, और रैम जो है 256 बाइट मिनिमम जो है, जो आपका है, वहां से लेके 4K तक जाएगा. और जो डेटा दिखा रहा है यहाँ पर, डेटा रैम, दिस इज एक्चुअली GPR. SFR इसके अंदर है ही है, मतलब. ओके, डेटा स्क्वायर प्रॉम जो है ये कुछ में नहीं है और कुछ में है, ये एडिशनल चीज है, बट ऑलमोस्ट सभी में 256 तो है ही है. सो दीज आर द वेरी पावरफुल फीचर्स ऑफ PIC जो दूसरे में आपको मिलेगा नहीं. इफ यू कंपेयर इट with respect to your 8051 Intels, then you see that there is a vast difference. Okay, and इनपुट आउटपुट पिन्स भी देखो, आप 16 से शुरू होकर 80 पिन तक जा सकते हो. एज मेनी एज IO पेरिफेरल्स यू वांट यहाँ पर मिल सकते हैं. सभी में ADCs है, टाइमर्स है, एंड दीज आर द पैकेजेस. नोट में आप देखोगे कि ROM, RAM, ROM मेमोरीज आर इन बाइट्स, ये सब बाइट्स में है. डेटा रैम जो है इज द अमाउंट ऑफ रैम अवेलेबल फॉर डेटा मैनिपुलेशन. स्क्रैच पैड वाला है ये डेटा, नॉट SFR वाला. दैट मीन्स GPR डेटा दिखाया हुआ है. इन एडिशन टू द स्पेशल फंक्शन रजिस्टर स्पेस, मतलब जो 128 बाइट्स है, फिर 256 बाइट्स है, अदर देन दैट डेटा रैम दिखाया हुआ है. ओके, सो हमने मेमोरी देखा कि रैम ROM क्या क्या होता है PIC के अंदर, स्पेशल फीचर्स देखे. ठीक है, नाउ विल सी कि IO पिंस, PIC इनपुट आउटपुट पिंस. पिन जो है आपको, you know well, if you are interfacing with number of peripherals, क्योंकि रियल वर्ल्ड में when you are developing embedded system, you'll interface with number of timer, counter, GPS, GPR, motors, anything that you are interfacing. तो उसके लिए आपको डिपेंडिंग अपॉन कितने इंटरफेसेस करने हैं, तो आपको नंबर ऑफ पिन्स चाहिए होगी. तो आप 16 से लेके 72, दैट मीन्स दिस मेनी नंबर ऑफ पोर्ट्स, पोर्ट A, B, C, D, E, F, G, H, इतने सारे 8 पोर्ट्स भी इसके अंदर है इनफैक्ट. एंड एज पर पैकेज नंबर ऑफ पिन्स अवेलेबल हो जाएगी. देन फॉर एग्जांपल 18F वाला जो सीरीज है, इसमें 16 पिन्स फॉर IO है आउट ऑफ 18. यू कैन सी दैट 18 में से 16 जो है इनपुट आउटपुट पिन्स है, बची 2 पिन्स तो आपकी पावर है. ठीक है ना, VCG और ग्राउंड. तो रिमेनिंग 16 पिन्स पूरे यूज होगा एज अ इनपुट आउटपुट पिन्स, जनरल पर्पस GPIO. और हाईएस्ट फैमिली आप देख रहे हो कि 8722 ये वाला, तो 80 पिन्स है इसमें, लगभग 8 पोर्ट्स आपको अवेलेबल हो जाएंगे. देखो, ठीक है, 8 पोर्ट्स में ऑलमोस्ट 64 पिन्स कंज्यूम हो जाती है, अगर 8 बिट का एक पिन मानो, 8 पिन्स का एक मानो. और दिस इज द स्मॉलेस्ट फुटप्रिंट, क्योंकि मेनी एप्लीकेशंस यू विल थिंक दैट मुझे तो एकदम छोटा सा फुटप्रिंट वाला 16 पिन का एक कॉम्पैक्ट सा IC चाहिए विच शुड डू द जॉब. देयर इज अ लॉट ऑफ वर्सेटिलिटी अवेलेबल इन केस ऑफ PIC, which is not the case with other controllers. Almost every manufacturer is trying to match with each other. Okay, now PIC peripherals. PIC peripherals में आपको वही टाइमर काउंटर जो है, it comes with almost every PIC का सभी फैमिली में आपको ADC, टाइमर, USART, इतने मिनिमम का तो सॉरी मिलेंगे. Okay, if we take a look at the comparison, ठीक है, कि भाई पॉपुलर 8-बिट माइक्रोकंट्रोलर्स बिसाइड्स PIC कौन से है. इंटेल्स के हमें पता है, मोटरोला के है, एटमेल्स के है, AVR सीरीज, Zilog के है. एंड इफ यू टेक ए लुक एट इट कि भाई हाउ इट कंपेयर्स विद रिस्पेक्ट टू द इंटेल्स, तो इंटेल्स का आपका 40 पिन पैकेज ले लेते हैं, और PIC का 18 का 14 पिन अगर पैकेज लेते हैं, दोनों 40 पिन पैकेज. सो इतने फुटप्रिंट में आपको इंटेल क्या दे रहा है, 64 किलोबाइट्स दे रहा है मैक्सिमम स्पेस, वेरेज PIC 18 आपको 2 मेगाबाइट्स तक दे सकता है. दैट इज द मेजर डिफरेंस, एंड दिस मैटर्स. एंड डेटा रैम जो है, ये देखो आपको 256 दे रहा है, एंड इट हैज गॉट 4 किलोबाइट्स मैक्सिमम. देन टाइमर्स भी इसमें 4 है, इसमें 0, 1, 2 होते हैं, इसमें एक एडिशनल है. देन इनपुट आउटपुट पिन यहाँ 32 है, यहाँ 33 है, दैट मीन्स 4 पोर्ट्स, मोर देन 4 पोर्ट्स आपको एडिशनल एक पिन अवेलेबल है, एंड सीरियल पोर्ट. सो इन ए सेम फुटप्रिंट 40 पिन के पैकेज में यू कैन क्लियरली डिस्टिंग्विश दैट PIC 18 इज द मच मोर पावरफुल. अब ये तो सिर्फ हम ऐसे देख रहे हैं कि इन टर्म्स ऑफ पेरिफेरल्स और क्या क्या फैसिलिटीज रिसोर्सेस है, ऑन चिप रिसोर्सेस क्या है. व्हाट अबाउट द स्पीड? Speed is totally different because this works on a RISC architecture, Harvard architecture. There is no match. Pipelining architecture, which is not the case here. So there is a lot of difference. अच्छा, some of the companies that produce widely used 8-bit, ये सब आपको शायद पता ही होगा कि माइक्रोचिप वाले भी 8-bit बनाते हैं. If you don't know, you can take these slides after finishing this if you want. माइक्रोचिप बनाता है PIC वाला सीरीज, इंटेल्स 805 बनाता है, एटमेल से आपको AVR सीरीज मिलता है विच इज ऑल्सो वेरी पॉपुलर इन द मार्केट. फिलिप्स, बट इसका एक मैंने एडवांटेज देखा है माइक्रोचिप का, दे गिव यू वेरी स्ट्रॉन्ग टेक्निकल सपोर्ट. इफ यू क्वेरी देम, देयर इंजीनियर्स आर, दे विल गिव यू सो मच ऑफ रिसोर्सेज कि आप कर नहीं पाओगे, इतने सारे रिसोर्सेज दे देंगे. देयर इज टेक्निकल सपोर्ट इज वेरी नाइस. देन एटमेल है, एटमेल में AVR सीरीज है, फिलिप्स की 8051 है, जीलॉक की है, ये वेरी रेयरली पीपल यूज, मैंने तो देखा नहीं जीलॉक का लोग यूज करते हुए. मैक्सिमम ये एटमेल AVR PIC यूज करते हैं. डलास का यूज करते हैं लोग. डलास में मेजर ये चीज था, डलास में डलास का मेन सबसे पहले जब ये आया क्या डिफ्रेंशिएट करता था, डलास में सबसे पहले एडिशनल इसमें इन्होंने RTC अंदर दे दिया, रियल टाइम क्लॉक. So many applications need कि भाई RTC भी होना चाहिए on chip, and so therefore Dallas got famous and popular from there. Dallas का एक 1307 chip है RTC का which is very popular, small 8-pin पैकेज है. और फिर on chip बैटरी के साथ भी है कि आपको बैटरी भी लगानी ना पड़े. Then Freescale, ये भी कम यूज करते लोग. Freescale is actually Motorola is taken over by the Freescale, so now it is known as Freescale. आपको पूरी और एडिशनल लिस्ट देखनी तो microcontroller.com की पूरी लिस्ट दी हुई है इसकी. ओके, सो कुछ ब्रेक LCD देख लेंगे हम कुछ, है ना. थैंक यू.